Hello and welcome everyone. Continuing with our C++ playlist where we have seen the pointers in the last lecture, I am going to talk about reference variables in C++ and how to build a reference variable and run it via the Visual Studio 2017 Community Edition. So watch on. Now, a reference variable, as you can see in this slideshow, is an alias or alternative name to an existing variable. As an example, if we want to make one person John as an alias to Tom, both being the name of the same person, we can refer that person either by Tom or John. References are often confused with pointers, but three major differences between reference and pointers are there. So we have seen that we can declare a null reference, but we cannot. We can assign a null pointer, but we cannot have a null references. We must always be able to assume that a reference is connected to a legitimate piece of storage. Pointers can be pointed to another object at any time. That is what we have seen in one of the examples earlier, where pointer was pointing to one object, but it was later reassigned to another object or another variable. However, once a reference is initialized to an object, it cannot be changed to refer to another object. Thirdly, the reference must be initialized when it is created. Pointers can be initialized at any time. So references are also known as aliases or alternate names, and they are um, represented by the AND symbol. And we have previously seen that where that AND was used. In C++, if you recall, the AND was used to denote the address of operator, which represented the address or memory location of a variable. However, when AND is used in a declaration, it is part of the type identifier and is used to declare a reference variable as this in this example. So for example, I have declared int I as 45. So if I want to make j as an alias of I, then I'll have to say int and j equals I, which means that we can declare an alias for I as j. And this actually reads that j is an integer reference to the reference initialized to I. The following is a code example of using reference of an int and double. So int main, within the int main function, we declare an integer variable and a double d, int I and double d, and then initialize their reference variables like j for I and e for d. So we write int and j equals I and double and e equals d, which means that j is a reference variable for of integer type, which is an alias of I, and similarly e is an alias of d. Both are of double type. And then we initialize I with 51, and we find that the value of I with this out statement is 51, and the value of I reference, which is j, is also 51. Similarly, for the d and d reference being the same, pointing to the same value, having the same value. So how the references work? References are nothing but constant pointers in C++. A statement such as int and I equals j will be converted to by the compiler to this statement int array constant integer array, which is a pointer, int pointer to an integer, a constant pointer to an integer I equals and j. That is, references are nothing but constant pointers. Constant pointers means that pointers who are assigned and declaration and they never change their value. They can't be assigned to or initialized to another memory. They need initialize because constants must be initialized, and since the pointer is constant, they can't point to anything else. Yes, that's the gist of the thing. To get the value pointed to by a pointer, you need to use the dereferencing operator asterisk or star. If p count is a double pointer, star p count returns the value pointed to by p counter that we have seen in the last tutorial on counters variables, on pointer variables. Now it is called dereferencing or indirection. This phenomena we have seen in detail. To assign an address of a variable into a pointer, you need to use the address of operator and. For example, p number equals and number. This is the address of the number which is stored in a pointer p number. On the other hand, referencing and dereferencing are done as references implicitly. For example, if ref number is a reference to another int variable, ref number returns the value of the variable. It simply does it as we have seen in the previous code here. So value of I with this cout statement which shows 51 and value of I reference j is also 51. All we had to do is to declare the reference variable j as being alias of I and assign to the value of I. So no explicit dereferencing operator should be used or needs to be used for the references. Furthermore, to assign an address of a variable to a reference variable, no address of operator and is needed. So neither this asterisk dereferencing operator, indirection operator, or the address of operator, they are not needed. Finally, we'll come to this problem, which is reference test.cpp. I have already written the code just for saving time. So I've declared the number 1 and number 2 as int type of variable and initialized their values as 88 and 22. And I have created a reference or alias to number 1. So the reference is known as ref number 1, which is a reference to number 1. And then I assign the value 11 to the ref number, which is an alias of number 1. And then I get the cout with this statement, ref number cout greater than ref number, and then cout, then I get this and number 1, which is, recall, just I'll give you 3 seconds. Right, if you have thought that number 1 is the address of this number 1, that you're right. And then in the next printout statement, it prints out the ref number, the address of this variable, the reference variable ref number, which is also supposed to be the same. And then ref number is assigned a different number, number 2, and number 2 is incremented, and then number 2 is now 22. So ref becomes, with this printout statement ref, I expect it to print out 22, and number 1 is also 22 because number 1 is now, ref number 1 is referring to the number 1, and ref number 1 has changed to this value 22, so number 1 has also changed to 22. And cout number 2 is, because number 2 is incremented by 1, so it becomes 23. Now let's run this application to verify. Now some of these things will change, this address locations, for obvious reasons. So it's keeping in line. The first is 11, that's fine, and this memory address is here, it's different from what we have got. This is only to be expected because that's just a way of showing what kind of memory. This is a hexadecimal notation, this is also hexadecimal. The hexadecimal memory address will be printed. Finally, this ref number is 22, and then number 1 is 22, and number 2 is 23. That's all for the day, and thanks for watching. If you like this video, put your likes, put your comments, and don't forget to subscribe. Thank you. Bye.